like I don't remember if I told you guys yesterday. I said yesterday to the other classes at least, in my personal opinion, I think triangle proofs are one of the easier ones because by this point, you know most of the most common types of properties, like definition of bisect and vertical angles, stuff like that. And you use that a lot within proving triangles congruent. And then your final statement or your final reason is going to be either side, 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 side angle, side, stuff like that, what we did yesterday. Okay? So I do just want to jump right into going through these two column proofs. So again, first thing we want to do is start with our given information. So we're given that segment LA is parallel to segment SN. Okay, so I want to label that on my picture. To label that those are parallel, we use those arrows. Okay. Make it a little more defined there. So those arrows indicate that those two segments are parallel. We're also given that segment LR is congruent to segment NR. Okay, so LR is right here, NR is right here, and we can label those congruent. Okay, next thing I want to do is look at the triangles I'm trying to prove. So I'm trying to prove triangle LAR is congruent to triangle NSR. Okay, so this triangle and this triangle. So next, since we're proving triangles congruent, I like to look for freebies. Okay, do you see any freebies within this picture? Anybody? Anybody? There's a freebie in here. These two? What are those called? Vertical angles. Okay, I do have a freebie in this picture. It's vertical angles. Now, since I labeled that freebie, I'll need to state that somewhere within my proof. Okay, you can't just label it and then assume that it's given to you. You will have to state it in your proof, and we'll get to that point when we start going through it. So as of right now, when I'm looking at my triangles, right now I have a side and an angle. Okay, I still need to use a piece of my given right here, right? That those lines are parallel. That means I can probably find congruent angle somewhere. So I'm going to need another congruent angle. So starting my proof, I'm given parallel lines. So using those parallel lines, okay, with a transversal LN, I can say angle L is congruent to angle N. Okay, so if these lines were your parallel lines, and this is your transversal, what type of angle pair are those? They're alternate interior angles. Do I use a converse for this? No, I don't. You're not using a converse because you are given lines are parallel. So that means you use if parallel, since your given lines are parallel, then I can say my alternate interior angles are congruent. Okay. In my next statement here, I had LR congruent to NR. Why did I have that?
That is given.
That was given.
Isn't the next one vertical angle?
Yes.
There's ASA.
Okay, so number 4, I have angle LRA and angle NRS congruent. Well, I labeled those congruent because they were vertical angles. That was my freebie. And that is by the vertical angle theorem. Okay, so if you have vertical angles, you label them. You can label those by the vertical angle theorem. Last one, I'm proving my triangles congruent. So So what I'm going to do is look at my picture. Just like we did yesterday, after I labeled it, I have a side between two angles in both of my triangles. So which one is that? Angle, side, angle. Not so bad, right? Oh, it's real bad. Any questions on this first one? No, you can do it. All right, looking at number 2 then. Okay, again, first we're going to look at our given. Okay, we're given O is the midpoint of MQ. Okay, well, if O is the midpoint, what does that mean about my segments? They're congruent. I have O as the midpoint of NP. So again, I have a midpoint, meaning that splits that segment into 2 congruent pieces. And I can label that right away. Now I'm trying to prove that triangle MON is congruent to triangle QOP. So we have MON, so that's this triangle right here. I want you to know which triangles we're talking about. So that's this triangle. And QOP, that's this triangle here. Okay, so we're looking at those 2 triangles. That's why it pays to look at which triangles you're trying to prove congruent, because this one you could have been doing these 2 as well. Okay, so look at which ones you're trying to prove. All right, so I'm starting with this piece of my given. O is the midpoint of MQ. Okay, O, midpoint of MQ. I want to use that to write my next statement. Well, what did I label on my picture with O, the midpoint of MQ? What did I label on my picture using that midpoint of MQ?
MO is congruent to OQ.
Yes, MO is congruent to OQ. Okay, so you're using that given information to write your next statement. Okay, why can I write those 2 are congruent? By the midpoint theorem. Okay, now that I've used this part of my given, I want to use the other part of my given. So I'm using O as the midpoint of NP. Okay, using that second part of my given information. Now with O being the midpoint of NP, what did I label on my picture? Yes. NO is congruent to OP. And again, that would be by the midpoint theorem. Okay. Now looking at my 2 triangles that I have to prove congruent, I have 2 sides already. So next what I'm going to do, since I don't have any other piece of my given information that I can manipulate or use, I want to look for freebies in my picture. Yes, Connor? I do have vertical angles. Okay, so I have this angle and this angle congruent. Okay, they're across from each other, created by intersecting lines. So that's what I need to write as my next statement. So I have angle MON. Yes, you have to write out how to label your angle like that. You can't say angle O is congruent to angle O. Can't say that. O is the vertex of 4 different angles. Okay, so we have MON congruent to angle POQ. Or QOP, doesn't matter. Okay, and again, those are vertical angles, so this is by the vertical angle theorem. Okay, so now I have enough information to prove my two triangles congruent, and I need them to match what I'm trying to prove, so this should be your last statement right here. So we have triangle MON congruent to triangle QOP. Again, just like yesterday, we're using the labels that we created. So I have an angle between two sides. So this is side angle side. Questions on 2? Okay, number 3. All right, so number 3, I'm given that WU and YV are parallel. Okay, I put arrows in there so that you knew they were parallel. And I have YU parallel to ZV. Okay, so these two are parallel and these two are parallel. Now I'm also given that WY is congruent to YZ. Okay, so I'm going to label that. Now I'm trying to prove triangle WYU is congruent to triangle YZV. Okay, so my two triangles here. So starting with my given information, I'm going to use that these lines are parallel again. So whenever I'm given lines parallel, that means you need to look for congruent angles. Okay? So if I have this line here, parallel to this line here, and WZ is my transversal. Okay? And I'm looking at angle W, okay, this angle right here, congruent to angle ZYV, this angle here. What type of angle pair is that? Remember?
Consecutive way. No.
Corresponding.
Yeah.
Those are corresponding angles. So I can say if lines are parallel, then my corresponding angles are congruent. Okay, so you need to use that those lines are parallel and pick out those congruent angles. So I need to do the same thing with my other set of parallel lines. Okay, so now I have YU parallel to ZV. Using this same transversal, I can say this angle right here, WYU, is congruent to angle Z. Why can I say those two angles are congruent? It's literally the same thing.
Yeah.
They're corresponding. So I can say if parallel, then corresponding angles are congruent. Okay, I do need to restate that because I was using a different set of parallel lines. Okay, so now I can look at my two triangles that I'm proving congruent. I have a side between two angles. So my reason would be angle side angle, because I have a side between two angles. What? No. No. All right. Number 4 is shorter. Okay, so number 4, I'm given AB is congruent to AD. Label what you're given. BC is congruent to CD. BC, CD. We're trying to prove triangle ABC is congruent to triangle ADC. So my two separate triangles here. So So starting with my given information, since I can't use those or combine them or anything like that to help me prove those triangles congruent, next I want to look for a freebie. What is my freebie in my picture?
AC is bisecting.
They share the same side. Okay? My triangles share the same side here. That is your freebie. You cannot assume angles are right angles. Okay? Do not say they are right angles. That's not a freebie. You can only say they are right angles if it tells you they are right angles. The only freebies that you need to look for are shared sides and vertical angles. Okay? So since they share this side, okay, it's equal to itself. So since I found that, I need to write that as one of my statements. Okay, so AC has to be congruent to itself. Because then I have it in triangle ABC, I have AC, and in triangle ADC, I have AC. Okay, and that is reflexive. That is the reflexive property. Something equal to itself. Okay? Now I can prove my triangles are congruent. My triangles that are congruent are here. That needs to be your last statement. So we have triangle ABC congruent to triangle ADC. Okay? What's my reason for saying those are congruent? Side, side, side. Questions on 4? All right, I want you guys to do 5 and 6.
Well, congrats.
SSS? SSS?
Mm-hmm.
Thank you, Grace, for letting me know. Who's involved?
She said, I won't be gone next week Thursday. I'm gone next week. Spent like 3 hours plus.
No, it's
I
not.
was
And then go to Facebook and go.
Say one more time, 'cause I can't. Yeah. Screw you, Isaac. You're making my math great bad. Just leave the one.
That was one of the ones.
No, it was pizza boxes.
We have to do 17.
How old are you?
Okay. If we just do like, and then.
Cute as frick.
Oh, just, because, and that's like yeah, it's right here, look at this, okay. Would we like,
You got me.
Can't say empty is correct. Not when you're bisecting an angle.
Yes, right.
Stop. No.
but I mean,
I'm serious.
but you go.
All right. So looking at number 5 and 6, I think most people got 5. You should have given, reflexive, and then side, side, side. Okay, you are looking at these larger triangles. Okay, so that one and then the other one here. So that's why PQ would be equal to itself. And then you had this entire side, MQ, and this entire side, PN. Congruent? And then my opposite sides there. Okay, so each of those triangles would be side, side, side. All right, this bottom one here. So I have, pay attention please. I have PN bisecting this angle. Okay, PN, it says nothing about bisecting this side. You should not say that these two are congruent. PN bisects this angle. That means it's splitting the angle into two pieces. So you'd say my two angles here are congruent. Okay? Then I'm also given MN is congruent to ON. Okay, that's my given information. Now, since I labeled these two angles congruent because I used my bisector, I have to write that as a statement. Okay, so I can write angle MNP is congruent to angle ONP. Okay, so this angle is congruent to this angle. That is by the definition of bisect. Okay, so I had a bisector, use definition of bisect. Okay, now I have a freebie within my picture. Okay, my two triangles share this side, so it must be equal to itself. So I do need to write that as a statement. So NP is congruent to NP. That is the reflexive property. And then my two triangles would be congruent by side angle side. Okay, you do need to remember what a bisector is. Okay, that's pretty important in your triangle proofs here. Okay, if it says bisector, it splits it into two congruent pieces. If it's bisecting an angle, you split the angle. If it's bisecting a side, you split the side. Questions? Okay, almost done. Number 7. In this one, we're given AD is congruent to CB. And we're also given that those two segments are parallel to each other. Okay? We're trying to prove triangle ABD, so this top one here is congruent to triangle CDB, so this bottom one right here. So I'm going to use my given. And again, since I'm given parallel lines, I want to pick out angles that would be congruent then. Okay, so if I have these lines parallel, with this line as my transversal, right? I can look at this angle here and this angle here. Okay? Shh. Hey, shh. Quiet. What type of angle pair would those two be? They are alternate interior angles. So since I was given lines parallel, I have to write if parallel, then my alternate interior angles are congruent. Okay, next I have DB is congruent to DB. That was my freebie here. It's a shared side between the two. And that is the reflexive property. Okay, next I can prove that my triangles are congruent. So I want to look at my labels. I have an angle between two sides. So that means this has to be side angle side. My angle between two sides there. Okay, questions on 7. Okay, I want you guys to do 8. Okay, you're given 2 sets of parallel lines, meaning you should find 2 sets of angles that are congruent.
It took like 4 weeks last time.
I didn't have owls though then.
She said SAS. I'm not stupid. I also got that.
Can you please say it correctly next time? It's AFS. Are you sure? BICTA. All right, I'm going to start going through number 8. So I'm using my given parallel lines. Okay, so given these two lines here are parallel, with this as your transversal, I know angle 1 and angle 3 would have to be congruent. And then given AB is parallel to CD, with this as your transversal, 4 and 2 would have to be congruent. Okay, so I can write out angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. I didn't realize that was all in the first step until I saw you guys doing it. Okay, so I can write both of those because they are by the same reason. So since these lines are parallel, each of these angle pairs here are alternate interior angles. So if I'm given those lines are parallel, then my alternate interior angles must be congruent. Okay, next I have a freebie with my two triangles. I have this side right here is equal to itself. So I do need to write that out. So I have CB is congruent to CB by the reflexive property. And then I can state my two triangles are congruent. So whatever I'm trying to prove should be my last statement here. So I have triangle ABC congruent to triangle DCB. And I have a side between two angles. So this is angle side angle. Any questions on our two column proofs today?